Hi guys, I Aziz welcome you to CoedMaster. I am going to talk about generic types. In this video, I will explain how to create generic types, how to invoke generic types, how to create generic types with one or more type parameters. So if you are willing to learn how to create and invoke generic types, then this video is for you. So make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, so in front of you, you will see a simple box class. This box class has one property of type object and it has two methods set and get to set that property. As the type of property is object, we can pass whatever we want to pass in this box class, right? And why is it so? Because object is a root class of all the classes. And according to Liskov substitution principle, whenever we are expecting a value of some type, then we can always provide a subtype of that type. So which means we can put integer to this box, we can put string to this box, we can put character to this box. There is no way for a compiler to figure out how this class is used. So for example, on some places in the program, you can place integer to this box and expect to get the object of type integer from this box. And on the other hand, you can place a string to this box and can expect to get the object of type string from this box. But guys, do you know there is a serious issue with this class? Let me show you what is the issue. So let's go to main.java class and let's create an instance of this box. Okay, so I have created two instances of this box, box 1 and box 2, and then I am putting these instances into a list of array. Okay, and then I have some logic to process all the elements of this list. So what I am doing here, I am taking all the elements of this list, storing it in a variable of integer and then printing it on the screen. But when I run this code, you will see that we are getting a class cast exception. Why is it so? Because we are expecting that this list has all the boxes and the type of all the boxes is integer. But by mistakenly, someone has added string to this box. But our code was written to handle only integers, right? So that is why we are getting a runtime exception. So which means when using the ordinary version of the class, we are not getting type safety feature first of all. And then second thing is the compiler is also relaxed and it is not putting any strong type check while compiling the code. And that is why we are getting a runtime exception and not getting the compile time error, right? And if you know guys, compile time errors are way easier to fix than runtime errors. Now how to solve this problem? So this is where generics comes into picture. So now I will show you the generic version of this class. So to update this class to use generic, we have to declare this class as generic class. And how can we do it? We can use arrow brackets like this after the class name, and we can declare or define the type parameter between these arrow brackets. So I have declared t as a type parameter to this box. So which means now we can decide ahead of time that to which type this box is associated with. So now we can replace all the occurrence of object with this t, and we can use this t all over the places in the class, and we are done. So we have successfully converted this ordinary class into a generic class. Now this class is not tightly coupled with object. Rather, it is coupled with a type parameter. And now we can decide that which type of object it stores. So let's go to main.java. Now, how can we invoke the generic classes? As simple as that. Just like we call our normal method with parameters, we can invoke generic classes using type parameter. We can invoke generic classes with type parameter. Okay. So let's write the arrow brackets like this. And then let's decide which type of object is this. So for example, let's say integer. Now this box is of type integer. Similarly, we have to write here also, put the arrow brackets and put integer. Now this box is of type integer, right? So here we are creating a new instance of generic class by passing integer into this type parameter. So which means the type of t is integer. So the property of this object type is also integer. Here also the type of this object is integer, and here also we are returning an integer, right? And we are storing an instance of this generic class object into this variable, and the type of this variable is box of type integer, right? And this is what we do in normal method call. We call method with some parameter. Similarly, we are invoking generic classes with parameter, and that parameter is of type parameter. So instead of passing value into it, we are passing type of the type parameter. Okay. Similarly, let's do here also. Let's put arrow brackets, then use integer over here, and similarly let's put here also. Now you will see that we are getting the type safety feature. Now it is not allowing us to add string to this box. And why is it so? Because now compiler understands that this box is of type integer and we are doing something wrong. So by using generic classes, we are able to catch the error at compile time rather than getting the error at runtime. Okay. So this is the advantage of using generics over ordinary classes. But guys, remember one thing, that generic always works with non-primitive types, right? We cannot pass integer over here like this. It will never work with the primitive type. It always works with non-primitive types. For example, any of the class type. It works with all the classes that inherits object class, right? So guys, I hope so far this is clear to you that how to create a generic version of an ordinary class. So now let me talk a little bit about naming convention of type parameter. So as you can see over here, I have used capital letter to define the type parameter of this class. And why is it so? Because by default, the naming convention used in generics is to use capital letters and the single letters. And this stands in sharp contrast to the variable naming convention that we normally use while declaring a method. So for example, here in this method, we are using the small letter, right? And the letter of the type parameter is capital. And why is it so? It's pretty simple. If we use small letters for declaring the type parameter, it would be very difficult to differentiate between type parameter and the ordinary method parameters, right? So well, it is always the best practice to use single and capital letter when declaring type parameters. Okay. So now let me show you all the most commonly used type parameter names, and these are E, K, N, T, V, SUV, etc. So you will extensively see the type parameter E in all of the Java collection classes. So whenever you see K, it refers to K. Whenever you see N, it refers to number, T refers to type, V refers to values, and so on and so forth. You will see other character also like S, U, V in all the Java SE APIs. So this is all about the naming convention that we use while declaring generic classes or generic interface or generic methods. Now the next thing is, many people often confused about the parameter and the argument. So what is the difference between parameter and argument? So here this T is what? Parameter or argument? And here what is this integer? Is it a parameter or argument? So guys, let me clear this confusion that the T here is the parameter. Okay. We can say that T is the type parameter of this box class, whereas here the integer is the argument to type parameter. So which means integer is argument. Using this integer, we are deciding that this box is of type integer, and here we are substituting the value of this type T as integer. Okay. So that is why integer is an argument and T is a parameter. I think this is clear to you. Now let's move on and talk a little bit about diamond notation. So guys, if you look at this code here, we are defining the type in two places. One here also before the invocation of the constructor of this class, and here also and here also. So don't you think we are redundantly defining the type of this class? Absolutely yes. So guys, here Java can help us to reduce this redundancy. So how can we do it? So in Java 7 or later, we can completely omit the type definition from here. We can completely remove it and we can simply use the diamond notation to define the type. Now the question over here is how compiler is going to know the type of this box object. So well, compiler can infer the type of this box object from the context here, as we are storing the instance of this box into a variable, and the variable of type is box of type integer. So from this context, compiler will automatically infer the type of this box, and it will pass integer to this parameter. As simple as that. So I hope so far everything is clear to you. Now let's move on to the next question, that in this class we have declared the generic type with one parameter. Now how can we declare generic type with two parameters? So now let me show you. So guys, you can see over here we have an interface, and this interface is a generic interface. And you can see over here is, instead of declaring one type parameter between arrow brackets, now we have declared two type parameters between these arrow brackets. So this is how we can declare multiple type parameters between arrow brackets. So this interface has two methods. One is to set key and one is to set value. So the type of key is k, and the return type of this method is also k. Similarly, the type of value is v, and the return type of set value method is also v. Now let's move on to a class which implements this interface. So we have ordered pair class, and this class is also a generic class. Okay, so instead of one type parameter, we have two type parameters now. Okay, now this class is implementing the pair interface, and pair interface is also a generic. So that is why we are using two type parameters here as well as here. Okay, now this class has two private properties, key and value, to store key and to store value. Now the type of key is k and type of value is v. Now remember one thing, that in both the type parameters we are using single letter and capital letter. Okay, so always remember this point. Now we have a constructor to initialize key and value, and then we are simply overriding two methods, set key and set value, to set key to this property and value to this property. Okay, so I think this is clear to you that we have one interface, and this is a generic interface, and we have a class. This class is also a generic interface, and this class is implementing generic interface. Right, now let's move on to the main.java class. Now here we are creating an instance of ordered pair class, and we are defining the type parameter as string and integer. So the first type of parameter is string, and the second type of parameter is integer. We can also replace this string and integer from here, and we can also omit this string and integer from here as well as from here. The compiler will automatically infer from the context. Okay, so as we are passing first type as string and second type as integer, so we can say that the type of key is string because we are passing a string as first argument to this type parameter, and the type of value is nothing but integer. Okay, and similarly the constructor of this class will also instantiate the type of this key as string and the type of this value as integer. Okay, and because of the auto boxing property in Java, we are able to pass primitive type into this constructor. Internally, compiler will convert this primitive type into non-primitive types, right? Because we are passing argument of type parameter as string and integer, and both are non-primitive types. Okay, so here first parameter is string and second parameter is integer. But on the other hand, while creating the new instance of the ordered pair class, the first argument to type parameter is string and the second argument to type parameter is also string. So which means in ordered pair class, the type of this key is initialized as a string and the type of this value is initialized as also a string, right? Because we are passing a string in both the arguments, and we are passing hello to this constructor and world to this constructor. Now not only that, we can pass type as the parameters type also. So for example like this. So here in place of a string we can pass integer, and here in place of a string we can also pass box of type integer, okay? And this is also valid in Java. So here we can pass 1 and then we can pass new instance of box of type integer, as simple as that. So we can not only pass the non-primitive types, but we can also pass non-primitive type of some type, okay? So this is how we can create generic classes and generic interfaces with one or more type parameters. So I think all of these things is clear to you. Now let's move on and talk a little bit about row types, okay? So let's remove this piece of code. Let's create a new instance of box class, okay? Let's name it box is equal to new box. Now you can see over here is, in spite of box having generic type declaration, we are still able to create an instance of box without defining the type, and this is what we call row type. So basically row type is the name of a generic class or interface without any type arguments. Now you may ask that what is the use of this row type? So guys, prior to JDK 5, the classes were not generic. So it might be possible that you encounter the legacy code where generics was not used. So in that case you can use a row type. So basically using row types, you are essentially getting the pre-generic behavior. So even if you have a generic class, you are not bound to always define the type parameter. You can create an instance of generic class without defining the type parameter. So guys, I hope this row type is clear to you, and now you have a good understanding of how to create generics, how to invoke generics, how to create an instance of generics, and how to declare one or more type parameters when creating generics. So in next video, I will explain how to create a generic method. So this is all from my side for this video. If you learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.